Now that we have an idea of what a system of differential equations looks like, we're going to look at solving them. And we're going to look at solving a very specific case. We're going to look at homogeneous systems with constant coefficients. So we need to know what these mean. We've talked about the normal form, x prime equal to ax plus f. So homogeneous says that this term right here is 0, so that I actually just have x prime equal to ax. The constant coefficient part says that this matrix A that we're looking at only has constant numbers. So the coefficients of x and y in my systems are just constant numbers. Here's an example of a homogeneous system with constant coefficients. If I try to put this in normal form, I have x prime is equal to, my coefficients are 2, -3, 1, and -2, times the vector x. I want to look at solving these. Solutions to these type of homogeneous systems with constant coefficients are of this form x equal to e to the rt times u. And so we need to learn a little bit more about this e to the rt u so we know how to find the solutions. Well, we can take the derivative. The derivative of e to the rt is r e to the rt, and u is a constant vector, so it acts just like a number. And in order to satisfy my normal form, x prime needs to be equal to ax. Well, I'm claiming that I know what x is, so this should be a times e to the rtu. I can divide both sides by e to the rt. Now I have ru is equal to au. Getting everything to one side of the equation, I have 0 is equal to au minus ru. I can actually factor out a u. And when I do, I actually have to write this as a minus ri. And this is to verify that things are still defined. I can't define a matrix minus just a number. And this ri is going to allow me to properly do this subtraction inside of the parentheses. Now that I'm at this point, I know that this thing right here needs to be equal to 0. So there's two cases for this. Two ways that this could be equal to 0. The first case, u is equal to 0. This is known as the trivial solution. The other would be that there is a non-trivial solution. And this happens if the determinant of a minus ri is equal to 0. So this will be our non-trivial. So this is the basic idea of what it is that we want to do. Let's actually write this process out step by step. Our first step is to write the system in normal form. The second thing we're going to do, we're going to use the determinant of a minus ri equal to 0 to solve for r. We then use a minus ri times u equal to 0 to solve for u. Finally, we're going to use both r and u to assemble our solution.